In this video, we're going to look at some tips for using interval notation. So if you aren't already familiar with it, interval notation is a really concise, efficient way to describe intervals. So whether that's intervals of a graph, intervals for solution sets, for something else, it's a much more efficient way than some of the others. And so that's why we use it a lot. So if you're struggling with it, here are a few tips for some of the things that are important and a few things that people tend to get hung up on. So first you want to start with notating from smallest to largest. So basically like reading from left to right. Okay, you'll never see it in any other order. And this is just so we are following a standard process. Okay, so there are two ways that you can describe the endpoints, which are really the key to interval notation. The first we'll look at is using parentheses. So you use parentheses if the endpoints are not supposed to be included. So this is where you see strictly less than or strictly greater than, or sometimes on a number line you would see an open circle. So it's everything up until whatever number is the endpoint of the interval. And to notate that, you just put a parenthesis around that number. Okay, you also use parentheses for negative infinity and infinity. And this is if your interval is what we term unbounded, or it just continues forever. And so I like to think about that as, well, you can't say, oh, we're ending at this number. And so therefore we'll use parentheses because the end is not included. Okay, we'll also use parentheses if we're describing intervals where we are increasing, decreasing, or remaining constant. And so this can vary depending on your class or on your textbook or your purpose. But in general, this is a very common way to use parentheses when you're describing intervals of increasing, decreasing, or constancy. And this is really because at that point of change, you are doing none of those things. So whatever it is you're describing, whether increasing, decreasing, or constant, and that's why we like to use parentheses. All right, next, the other type for interval notation, the notation you would use is brackets. So that's the square bracket. And we'll use that when we want to include the endpoints. So unlike the previous with parentheses, we have, say, a closed dot on a number line, or you'll see the signs greater than or equal to, or less than or equal to, if you were looking at an inequality. So that's when we'll use brackets. Okay, a couple of other notes. You'll use a U, a capital U, it almost looks like, to notate the union of two sets. And so that's if you have two or more intervals where you are increasing, if you were describing intervals, or if you had two different intervals for solution sets, you would use this U to connect your two notations of those intervals. And finally, I like to say you should think about the X values describing the Y's, or even simpler, the X's describe the Y's. So sometimes people get confused and try to put the Y values in their interval notation. They have no place in the interval notation. All we need to do is write the X's, and we'll see that in practice in just a minute. And so everyone will know, okay, we're using these X intervals, these X special points to describe what the Y's are doing, whether it's increasing, decreasing, remaining constant, solving, whatever it is, X's describe the Y's. All right, so let's look at some examples. Okay, so we have just this number line, and we see that we have two different intervals, as denoted, of course, by the shading. So when we are describing this in interval notation, we go from the smallest to the largest. So let's start with the interval on the left, the smaller one. Okay, we can see that it's unbounded. That arrow indicates that it goes on forever toward negative infinity. So that's where we're going to start writing this interval. So we'll write from negative infinity, and notice that we use a parenthesis around that because that was part of our tip. Okay, then all you have to do is put a comma. So we've said we start over here as much as you can start at an infinity, and it's all shaded. We don't have to deal with any of these numbers until we get to the end point of this particular interval. So we record that number, -1, and we just need to decide parenthesis or bracket. And in this case, you can see a closed dot. We want to include the -1, so we'll put a bracket, and that includes -1 as part of our interval. Okay, and this is one of those where we need a union, so we draw our uppercase U to show that both of these sets are part of our solution. And we can move on to our second interval. So we see already we start with the endpoint 4. So record the 4, but notice the open circle. So we should put a parenthesis around there because we don't want to include the 4, but we want everything past that. Okay, put a comma. And then we see we're continuing on forever is what this arrow means. So we'll mark that endpoint as positive infinity, and we'll close it with a parenthesis because that's our notation. It's an unbounded interval. All right, so that is one example. Let's take a look at one more. So this is a little bit simpler one, but sometimes this notation can confuse people because it almost looks like an ordered pair. So let's see what that does. Okay, so we're writing just a single interval here. Look at the leftmost endpoint, so that's here. We'll write -3, even though we see it's clearly not included. That's what the open circle indicates. So we'll use a parenthesis, okay? And we want to say everything between -3 and you can see we go all the way to 2. So all we have to do to indicate that is -3, comma, 2. Okay, and we want to include 2, so we'll indicate that with a bracket. So this small, concise notation right here is interval notation to express all the numbers between -3 and 2, not inclusive of -3. And you can see that's a little bit strange. It takes some getting used to, but once you're used to it, it's much more efficient than, say, even the inequality notation, which would be -3 is less than x, we'll say, is less than or equal to 2. Okay, that's not too bad on its own to write, but you can imagine if there were many more intervals, you would start to think, okay, that's just a lot going on there, a lot of inequalities, whereas the one on the left is what we should get used to using. It's much more concise. All right, so hopefully this helped a little bit with interval notation. Keep practicing and you will get it in no time.